Hello and welcome to the Makeup Lab for Unit 11, Nuclear Chemistry, Nuclear Half-Life Simulation. Purpose: a half-life is the time required for one half of the atoms of a radioisotope to emit radiation and decay to products. After one half-life, half of the radioactive atoms have decayed into atoms of another element. After another half-life, only a quarter of the original sample remains. After another half-life, only an eighth remains, and so on. Because the concept of half-life is probably new to you, you might conclude intuitively that it takes 1 hour for a radioactive isotope to decay, and then it should take only another hour for the other half to decay. This conclusion is based on the false assumption that the rate of decay is linear, constant over time. In fact, radioisotopes emit alpha and beta particles to decay in a nonlinear fashion. The rate of decay will slow over time, so that the more time that has elapsed, the more slowly the decay proceeds. The reactants of many chemical reactions that involve no radioactivity at all react to form products that is an easily measurable half-life. In this lab activity, we will use a piece of magnesium ribbon to simulate our radioactive material and to expose it to factors that will break it down over time, similar to a radioactive substance experiencing radioactive decay. Description of setup. At each lab station, there will be a beaker with 1 molar hydrochloric acid along with preloaded plastic pipettes containing potassium hydroxide and phenolphthalein indicator solution. There will also be 2 small plastic cups which will be used to run the reactions, as well as a pair of forceps to be used to handle the magnesium ribbon between trials. It is strongly recommended that you bring at least 2 paper towels to your lab desk. 1 paper towel is to be used exclusively for drying the magnesium ribbon between trials, while the other will be used to dry the plastic cups between trials. As you can see here, we have 8 cups numbered from 0 to 7. 0 is going to represent the trial that titrates the full quantity of HCl called for in the procedural steps, which is 10 drops. Currently, there are 10 drops of 1 molar HCl into each of these cups. Only cups 1 through 7 are going to have magnesium added to those cups for a reaction to proceed for the designated time interval. 10 seconds in cup 1, 20 seconds in cup 2, 30 seconds in cup 3, so on and so forth, until cup 7 receives the magnesium for 70 total seconds. After the magnesium is removed, and for cup 0, 1 drop of phenolphthalein will be added, and that's the indicator. And then potassium hydroxide, a base, is going to be used to titrate that HCl. The number of drops of KOH that is determined will be the number of drops that are recorded in the data table along the bottom row for each of those runs, run 0 through run 7. A titration has us figure out, with the addition of a base, how much acid is there. In this dropper, I have the phenolphthalein indicator. I'm going to add 1 drop of the phenolphthalein indicator to the HCl in the cup. There's only a small amount of the HCl in the cup, as you could probably see there at the bottom along that edge. This one, there will be no reaction with magnesium. So with the indicator and the acid together, I'm going to take potassium hydroxide and add it drop by drop until the indicator turns pink and stays pink. 1, 10, 20, 30, 40, 50, 60, 62 drops. And that 60-second drop, it turned pinkish and it's remaining that pink color. 62 drops is what you want to record in your data table for run 0. The only difference between run 0 and runs 1 through 7 is that magnesium will be reacted for the duration of time, multiplying that cup number by 10 seconds. So that was 10 seconds for this first piece of magnesium ribbon. I'm using this stopwatch here, since it's just me that's doing it. Starting the time and putting the magnesium in a particular number of seconds. So this will be 20 seconds, starting at 7. Trial 3 at 40 for 30 seconds. This one will be stopped at 70 seconds. Or a minute 10. This will run for 40 seconds to 45 seconds total elapsed time from starting at 5. $40 seconds for that one. This will be in for 50 seconds. Starting at 10, so removing the MG at a minute. So 50 seconds elapsed time. Run 6 for 60 seconds. Starting at 10 seconds. going to 1 minute and 10 for a total of 60 seconds. So that was 60 elapsed seconds. And lastly, for run 7, this one will react for 70 total seconds, bringing me from 10 seconds to 1 minute 20. The sign of the reaction that's occurring for each one of these, if not mentioned previously, is bubbling, being the magnesium metal reacting with the HCl. So we have bubbles as that sign of reaction each and every time. Approaching 1 minute 20. At this point, the HCl has reacted with the magnesium for different quantities of time. In each successive trial, more reaction occurred. Therefore, for each trial, more HCl would have been used up. So ideally and theoretically, we'll end up with a situation that has us using less and less drops of KOH in each titration. But in order to determine where that endpoint lies, 1 drop of the phenolphthalein is needed for each one of these trials. Now it's a matter of titrating with potassium hydroxide until each run achieves that endpoint, and then recording that number of drops for that trial. One, 10, 20, 30, 40, That was at 45 drops. There may not have been enough phenolphthalein. We have to run 1 again. Make sure that doesn't happen again. Adding an additional drop of phenolphthalein to each cup. So run 1, we need to do again. Run 2, 1. Ten. 20. 25. 27 drops to be recorded for run 2. One. 10. 19 drops to be recorded for run 3. Ten. 'Looks like it's turned pink and it's staying pink, though faint. 16 drops to be recorded for run 4. Run 5. Ten. 13 drops to be recorded for run 5. Run 6. Nine drops to be recorded for run 6. Run 7. Seven drops to be recorded for run 7. replacement run. For run 1, we'll need 10 additional drops HCl, drops of HCl, react with magnesium for 10 seconds. Use the same piece of magnesium that's left over, starting at 10. Well, that didn't go well, as things happen. They say the third time is the charm. 10 more drops of HCl. Looking for one more drop. In at 5 seconds, cross your fingers for me. Got it. Phenolphthalein. Now titrating with the KOH until the pink endpoint. One, 10, 20, 21, 'That was 36 drops. A lot better than the 45 or so that I got for the original run 1. So make sure, recording all those drops, go back in the video if necessary to get the drop quantity for each of those trials, if needed. Completing the lab and getting your lab to your instructor. And this has been the makeup for Unit 11's lab, Nuclear Half-Life Simulation. Thank you.